Now I have the opportunity to talk about the factors affecting enzyme activity. Here they said that write short notes on any 5 factors affecting enzyme activity. So let me see how many I actually brought because there are actually many, right? Factors affecting enzyme activity. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So I brought like 9 so that you just select anyone you want and work with it. But they will hardly tell you to list more than 5. 3, 5 is the number they always talk about. All right. So it's just literal. I don't even need these images for you guys to understand this, okay? Because from the explanation you understand. So the first one I'm picking is temperature. So let's have the overview. So that enzyme activities can be influenced by several factors, each of which can actually alter the rate of the enzyme activity. Is either if the factor is increasing the rate of action of the enzyme or is decreasing it. Do you understand? So we have the action of the effect of temperature. What is the effect of temperature? So enzymatic activity typically increases with temperature due to kinetic energy of molecules, okay, leading to more frequent collisions between the enzymes. Mind you that we are talking about high temperature here, okay? What if the temperature is optimum? So each enzyme has an optimum temperature at which it is most active. Okay. So for many human enzymes, the temperature is around 37 degrees body temperature. So the thing is, the temperature can be going high. The enzyme activity will be, yes, it will be to increasing, but it can get too high that the enzyme can get denatured. You get. So now let's look at denaturation. High temperatures can cause the enzyme to denature, losing their structure and function. Okay. Now the next one is pH. Talking about pH. What is the effect of pH? Enzymes have an optimal pH range in which they function best. Deviation from the range can alter the enzyme's shape and reduce its activity. Some enzymes they work best when the pH is acidic. Some enzymes they work best when the pH is what? Neutral. Some enzymes they work best when the pH is basic. You can't really say one thing for all. Alright. So let's look at the optimum pH. So different enzymes have optimum pH values. For example, pepsin, that is a stomach enzyme, works best when the pH is 2. That's acidic. Trypsin works best when the pH is basic. Okay. So what is the substrate concentration? Substrate concentration is basically what? Let me see. Substrate concentration is basically the amount of work or the amount of substance that the enzyme is supposed to work on. If you do too much work, you become tired, right? So what is the effect? Increasing substrate concentration typically increases the rate of reaction as more substrate molecules are available to actually bind to the enzyme site. But when it becomes too much, that's when we are talking about saturation point. So once all enzyme active sites have been occupied, there's no vacancy. Okay? So that's the saturation point. So further increase in the substrate concentration does not increase the rate of reaction, but it rather just stop it, okay? Or just keep it at a steady flow. The enzyme concentration. So now we are now talking about the ratio of the enzyme. If enzymes are much, okay, they will act more. Do you understand? So higher enzyme concentration generally what increases the reaction rate as more enzyme molecules are available to actually catalyze the reaction. Okay. Then what is the limiting factor? The reaction rate will plateau or will steady if the substrate concentration becomes a limiting factor. So if there are no substrate for the enzyme to act on, no reaction will go on. Okay. The presence of inhibitors. Let's see if this one is included here. Yeah, inhibitors. So if the inhibitors are competitive, they are competing with the enzyme, they are competing with the substrate for the active side of the enzyme. Do you understand? So molecules that resemble the substrate actually compete for the active site, and this will reduce the enzyme activity because what is binding to the active site is not what the enzyme wants, just that the thing looks like what the enzyme wants. But enzymes are specific. You get? Then we have non-competitive inhibitors. These ones, they will not bind to the active side of the enzyme. They will bind to another site of the enzyme. But when they bind to the other side of the enzyme, they will now change the shape of the active site. Okay? So now the substrate will not be able to fit into the shape again. Okay? So these molecules, they bind to an enzyme at an other site than the active site, and this will cause a conformational change. And this will what? Reduce the enzyme activity. The presence of activators. I won't go back again, I'll just go, right? So activators are molecules that increase the enzyme activity by enhancing the enzyme ability to bind to substrate or stabilize the active form of the enzyme. They have ionic strength and presence of salts. Ionic strength and presence of salts can affect the enzyme activity by altering the enzyme structure, okay, or by affecting the interaction between the enzyme and its substrate. The cofactors and coenzymes, which we have already made many videos on it. Some enzymes, they require what? Cofactors. These are inorganic ions or could be organic, but coenzymes are only organic. You get for their activity. So availability of these molecules can actually affect the enzyme function. All right. So let's look at the post-translational modification. So enzymes can be modified after translation. That's like phosphorylation or acetylation, which can actually alter the activity, the stability, and interaction with other molecules. Okay. So on that basis, those are the factors affecting enzyme activity. Only required is 5. Okay. But we spoke much more though. Just find any ones you like and work with it.